Hey guys, and welcome back. So now we're going to start looking at the upres workflow, and I'm going to use a simplified RBD system to properly illustrate the concept. Once we fully understand the basic principles of this method, we're going to then start implementing it on our main setup and add all the necessary features for us to do it properly. We're also going to look at something not necessarily an upres, but we're going to add extra elements. I'm not so sure how to call this, but we're going to add another level of details to the geometry by replacing or swapping something that was low res with completely different geometry, and we'll talk about this in the next video as a second concept for the whole upres workflow, and then we'll start implementing it in our main sim. So here I have this box falling. I used the shelf tool to create this, and what we need is we need the geometry. So let's call this main layer, and we're gonna consider this as to be our main sim. Okay, and let's I need the packed geo, so this guy, and then the RBD points, so that guy, and this is the geo. And these are the RBD points, and it's used transform pieces. Cool. So we have our geometry moving, and the idea is we want to upres these guys. We want to add more details to each one of these guys. So I'm going to use a for each loop and simply fracture that. So for each connected named primitives, and let's loop over each one of the pieces and add more details. I'm going to copy a simple Voronoi section here, just these two nodes. Okay, and let's add more details. I'm also going to fuse the geometry before we fracture it again, just to make sure, because this one has separate faces. So we want to fuse that, and then I want to delete all the groups because it has inside and outside, just to keep it clean. And now we have upres each one of these guys. And the idea is we want to transform this new geometry now using the same transform pieces method. So let's copy that, and let's connect it here and see what we get. And it is not working. The reason for that, anytime you see an issue like this, it's primarily driven or due to the name attribute being not set up correctly. And that's what happened. We overwritten the name attribute. So if we look here, we have our name attribute, and then after we did the Voronoi fracture, it made a new attribute called name, and now it's 100 unique pieces. And if we look at it, it's still 100 because the same pieces are being named the same way, but we've overwritten the same guy. So what we need to do is we need to preserve that, and I'm gonna store the original one in at name origin name. I'm gonna call it origin name, and it's equal to the name attribute. So now whatever happens to the name attribute, I don't care anymore because I have a backup plan. Okay, so we have this, and let's take a look. Still the same. If we take a look at the transform pieces, there's a name here, so we need to tell it which attribute to look for, and in this case it's origin name, but it's still not working. And again, the reason for that is the point attribute. They don't have this guy. They still rely on the name attribute. So we need to make the same thing here and make a copy of the name attribute, and this time it's point because it's point attributes. And there we go. Our pieces are now falling and following everything, respecting this main sim. And the idea is we want to use this sim in a separate RBD system. Okay, we want to use these guys and tell them, basically turn them to be active based on certain condition. Okay, so let's create that. Let's first assemble all of this. So after we made the name and all of this, we need to regenerate the name attribute because the for each is not giving us what we want. So let's call this appraise, and we should see 1,000 unique names. Cool. And let's go up, call this out rbd appraise, and we also need to pack it. Right now it's unpacked geo, so let's pack this guy. And if we unpack it, it's not liking that, and the reason for that is after we did the packing here, we lost that name origin. By default it only transfers the name attribute, so we need to tell it to also transfer the name origin to the points. Okay, so not here, sorry. Yeah, this guy. Yep, so let's see. Cool. So we need to transfer that to the packed primitives, or we could do the packing afterwards, but I don't like that because we keep repacking it every time, and I like to pack it once and then transform it if I have to. So let's create a dot network. Call this rbd appraise. Let's copy this guy, rbd packed object, and let's call this rbd appraise. We need a bullet solver, we need a merge node, we need a ground, and we need a gravity. Okay, let's hit play, and it's working. Let's see what's gonna happen. And everything is active. So what's happening now if we set this, give this a velocity, for example, angular velocity of 50, and hit play, it's going to start reacting to this. And it's not inheriting any of the previous animation. Okay, we don't want this. We don't want this behavior. So what we need to do is we need to change this to create static object. And once we do that, it's not falling anymore. It's not respecting the previous animation. And to fix that, we need to create animated static object. This is the method we need. So if we hit play now, it's gonna match 100%. Okay. And but it's still the same, nothing happened. What we need to do is we need to provide this anim with a trigger to tell it which pieces to activate. And for now I'm going to change this back to create active, and we are going to specify the activeness at the top level. Okay, so let's use a wrangle node, and the active is equal to 0. So here it says active. Yeah, let's set it to 0. Yep. So if we hit play, nothing happens. So we're overriding that active attribute. But with this thing, it only happens once, and we want to change the activeness over time. So for now, I'm going to keep only the active so that it gets overwritten every frame. And then I'm going to add an expression here. If at frame is higher than 20, I'm going to change the active to 1. And let's see what's going to happen. So as you can see, after frame 20, all the pieces became active, and they started falling. So the other thing we want to do, if you guys remember the list, it had animated and deforming. We don't care about deforming. We care about animated attribute. So let's initialize this. Let's set it here. I at animated equal 1. Okay, and let's go back. Let's hit play and see the objects are moving because the animated value is set to 1, and this means go update the position every frame from the sub level, and so we're getting this. And if we delete this, let's set this to 0, we have active to 0, and we have animated to 1. So if we hit play, it's gonna match exactly what's happening. And this is mapping to this create animated static object. This is what we did now with the attribute, but look here, we have that set there. And what the main thing is, we want to be able to drive the activeness and animate it automatically. So what I want to do is, I'm gonna say if we got to frame 33, I want to stop the animation. So I want to turn off the animated feature so they don't inherit anything, and I want to make them active. Okay, so let's go back up, and we have this now. I'm going to say if frame is higher than 30, I want to swap these guys. I want them to become active, and I don't want them to inherit any more motion coming in from DOPs. Let's go back, and there we go. Everything became active at that frame. So we inherited half of the anim, and then we made them active at that frame. And this is how you deal with receiving or working with animation. Given animation, let's say you have a couple of rocks falling and they hand animate those guys. You want to maintain that animation and then set trigger points or specific frames that you want to switch them to become active. And so that's how you retain the motion. And even though, see, this set to 500, it didn't affect the initial state because we wanted to keep that motion as it is. Okay, so but now the activeness is a bit silly. It's not interesting at all, and I want to create something more interesting. And the more interesting thing is, I want to create, basically select these guys and have them start to become active over time. Okay, so I want to trigger these guys to become active first, and then these guys, and so on and so forth. And I'm going to do a very simple system for that, just to illustrate here. So I'm going to isolate the interior faces, and I'm going to scatter a lot of points on this. Okay, and I'm going to, let's copy this. I just need active attribute, so it's 1 here. Or you know what, let's set something else. Let's set a color attribute. So we can see it visually. So I want the color red, and then here on these guys on the pack geo, I'm gonna set the color to black. I'm gonna use an attribute transfer. And with the attribute transfer, we want to transfer CD, and I'm going to lower the amount. And with the packed primitives, it's we're not going to be able to visualize these attributes properly. And what we need to do is we need to use a blast node to view the pieces, or the pieces that has the correct value. So in this case, I'm going to isolate anything that has the red channel lower than 0.5. And it's a point. You can see we're isolating specific pieces. I'm going to lower this. And so what I'm going to do is I'm going to animate this threshold, animate this transfer to start 0 at the first frame. So nothing is has the red color, and then over time I'm going to set it to maybe 0.5 or 0.6. So let's do that. Let's go to frame 70, set it here, and frame 0, I'm going to set it to 0. And as we play through, we're going to start seeing pieces being added. And I'm going to use this information to drive the activeness. So let's connect this. I'm not going to use this blast here. We're simply doing the color thing. And let's set the color back again here. Okay, and I'm going to say, instead of frame, if cd.x is higher than 0.5, we want this to be true. And remember, this is gonna change. So over time, these guys are going to become active, and they're gonna have the animated attribute set to 0. Okay, and then we're resetting the color just to be safe. Let's take a look. Hit play. Nothing is happening. And then as they hit the ground, or it's not based on the ground hitting, but as we get closer, the pieces are now, the surrounding edges are now activating, and the core is still intact. See, they activated beforehand. These guys are now active, you can see that. And then once they hit, we still, all this is inheriting the previous motion, so we're not changing that. We're only introducing this motion. Cool. So that's basically the concept. And as you can see, we're not activating everything. So out of this, we're not activating all these chunks. And that saves a lot of time, even if we increase the number of pieces. I think it changed. Let's go crazy. Let's try 1,000. So we're only activating the shell, which is this much, and it's a lot of pieces, but it's not as high as if we were to activate everything. Okay, and we're also not using any constraints or anything, so it's really, really fast to do these kind of techniques. Let's try it with 1,000. And it's best to look at it without the wireframes. And pieces are now starting to activate. You can see the time is getting slower and slower. You can see the cracks there. And we kept our main sim. As you can see, we're not changing that. And look at how fast this is. And so we're going to implement the same technique on our main sim, but we're not going to use the color to drive this. We're going to create something much more intelligent for triggering the activation. Cool. So let's I'm going to talk about another thing to add, another method to do the upres. I'm going to lower this back to 100. We're going to talk about a different method to swap the geometry. And actually, before I move on, I want to change something here. Let's go back. I'm going to save this. I saved already this on live. I'm going to save this as a swap technique. And apart from this, I want to add another object. So I'm going to copy all this. Actually, I'm going to copy all this. And I'm going to template this geometry. And I want to make a thin box on top of this. Something like that. Okay, and I'm going to fracture it. And let's change the scatter, maybe 20. And I'm going to name this top. And let's create a null object. Top layer. And let's update the RBD system, the main layer. So RBD packed geo, packed object, and I want this. So now we have two objects overlapping on top of each other. If we hit play, we get that. Cool. So this is the base layer for another technique that we're going to look into in the next video. Thank you guys for watching, and see you in a bit.